Hidden in the depths of our solar system, beyond the reach of the known planets, an icy world drifts on an orbit so bizarre that scientists are left baffled. Could Sedna be evidence of a hidden ninth planet, the remnant of a passing star, or even an interstellar wanderer from another system? Sedna is one of the most enigmatic objects in our solar system, an icy world that travels through the farthest reaches of space on an orbit so elongated that it defies easy explanation. Discovered in 2003, this distant trans-Neptunian object takes more than 11,000 years to complete a single orbit around the Sun, moving through regions of space that no other known planetary body regularly inhabits. Unlike the planets and even most of the Kuiper belt objects, Sedna never comes close enough to be significantly influenced by the known giant planets, and its orbit extends far beyond the scattered disk of icy bodies beyond Neptune. The extreme distance at which it orbits raises profound questions about how it came to be where it is, what forces shaped its trajectory, and whether it might be part of a larger, hidden population of objects that provide clues about the early history of the solar system. Sedna's discovery introduced a new mystery. How could an object have been placed on such an elongated orbit when there were no known forces that could have done so in the current solar system? One possible explanation for Sedna's peculiar orbit is that it was influenced by a passing star early in the solar system's history. During the time when the Sun was likely born in a dense stellar nursery, interactions with nearby stars could have gravitationally nudged small icy bodies, like Sedna, into highly elongated orbits. If Sedna was perturbed during this era, it would have been flung outward, permanently stranded on an orbit that never returns it to the inner solar system. This scenario also raises the possibility that there are many more Sedna-like objects waiting to be discovered in the farthest regions of the solar system, relics of an ancient time when the Sun was not yet alone in its journey through the galaxy. However, there is no direct evidence of such a stellar encounter, and alternative theories suggest that Sedna may have been influenced by forces much closer to home. Some researchers propose that an as yet undiscovered large planet, sometimes referred to as Planet 9, could have perturbed Sedna's orbit, shepherding it into its current path. If such a planet exists, its gravity may have shaped not only Sedna's motion but also the orbits of other extreme trans-Neptunian objects, offering an unseen explanation for the strange clustering of orbits that astronomers have observed. Another fascinating possibility is that Sedna's orbit was sculpted by forces from beyond the solar system itself. Some researchers speculate that Sedna may have been captured from interstellar space, perhaps forming around another star before being gravitationally snatched by the Sun's influence. If this is the case, Sedna may be one of the first known objects to have originated outside of our solar system, a cosmic wanderer that now offers a glimpse into the planetary formation processes of other stars. The interstellar capture hypothesis aligns with the growing understanding that planetary systems are not isolated but rather dynamic environments where material can be exchanged between stars under the right conditions. Such an origin story would make Sedna an even more compelling object of study, as its chemical composition, surface features, and internal structure could provide evidence of a formation history unlike anything else in our solar system. Spectral analysis of Sedna's surface suggests that it is covered in a mixture of frozen methane, nitrogen, and complex organic compounds, hinting at a history of chemical processes that could offer clues about its place of origin. However, without a direct mission to explore Sedna up close, its true history remains elusive. The implications of Sedna's orbit extend beyond the mystery of its formation. Because its extreme distance places it in a unique region of space, it is largely unaffected by the gravitational disturbances that influence objects closer to the Sun. This makes Sedna an ideal candidate for studying the primordial conditions of the solar system, as it has likely remained relatively undisturbed since its early days. Understanding the population of Sedna-like objects, if they exist in large numbers, could help astronomers determine whether the solar system has undergone significant migration events, been influenced by external gravitational forces, or even been shaped by interactions with rogue planets. Some researchers suggest that Sedna could be part of an entirely new class of objects, forming the inner edge of the hypothetical Oort cloud, a distant shell of icy bodies that is thought to be the source of long-period comets. If this is the case, studying Sedna could offer an unprecedented window into the structure and dynamics of the outermost regions of the solar system, potentially confirming the existence of an extended population of distant bodies. Despite the vast scientific interest in Sedna, its great distance and slow movement make it a challenging target for direct study. At its closest approach to the Sun, it is still nearly 3 times farther away than Neptune, making even the most advanced telescopes struggle to resolve its features in detail. Future space missions, perhaps similar to New Horizons' flyby of Pluto, could provide a closer look at Sedna's surface and composition, helping to unlock its secrets. However, given its incredibly long orbital period, any mission to Sedna would need to be carefully planned to take advantage of the rare moments when it is within a reasonable distance for exploration. The study of Sedna and similar objects represents one of the last frontiers in planetary science, offering a unique opportunity to probe the conditions of the early solar system, test models of planetary migration, and search for signs of yet undiscovered influences that have shaped the outermost regions of our cosmic neighborhood. As technology advances and more powerful telescopes come online, astronomers may one day uncover the full story of Sedna's journey through space, revealing whether it is a lone oddity or part of a much larger, hidden structure that has yet to be mapped. Sedna's mysterious journey through the cosmos challenges everything we know about the outer solar system. As astronomers continue to search for answers, could this distant world be the key to unlocking the secrets of our cosmic past?